Howdy everyone, I am Mohammad Ahmad Qureshi, working as an assistant professor in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. Today, we will learn analysis examples related to WRC beam in the subject Design of Structures. In the previous lecture, we had solved two examples related to WRC beam analysis portion. Now we will go for another examples. So, in this example, it is given that a doubly reinforced beam of 230 into 500 mm deep, that is, width is given as 230 mm and 500 mm deep, that is overall depth is given as 500 mm. Hence, it is reinforced with two numbers of 16 mm dia bars as compression reinforcement. Means here it is two numbers of 16 mm dia bars and four numbers of 20 mm dia as tensile reinforcement. So here four numbers of 20 mm dia bars AST is given. Then effective cover on both sides is 50 mm. That is D dash is 50 mm and effective cover is 50 mm in the tension zone. So the overall depth is given as 500 mm. So our effective depth will be 450 mm. That is 500 minus effective cover 50. So effective depth will be equals to 450 mm. And using M20 concrete and Fe250 grade of steel, we have to find the moment of resistance Mu. So first of all, we will write the given data. So here FCK is given as 20 Newton per mm square and Fy is given as 250 Newton per mm square. And the area of reinforcement in the tension zone AST is given as 4 dash 20 mm dia. So using SP16 page number 229 or using the equation n into pi by 4 into d square, you may get the value of AST as 1256 mm square and the area of steel in compression zone ASC is given in the data as two numbers of 16 dia bars. So using SP16 page 229, we will get ASC as 402 mm square. So the area of reinforcement in the tension zone and compression zone has been calculated by us as given in the statement. Now we have to find the value of FCC and FSC. So for this value, we use SP16 page 13. So we will get FCC equals to 0.446 FCK and value of FCK in the given statement is given as 20. So we will get the value of FCC as 8.92 Newton per mm square. Now, this equation lies in SP16 page number 13. Now, we have to calculate the value of FSC. Now, Fy is given as 250 Newton per mm square. So, we may use the equation FSC equals to 0.87 FY. For FE415 and for FE500, the value of FSC can be calculated using the table that is given in SP16, page 13, table number F. That is stress in compression reinforcement in doubly reinforced beam. But for FE250, we have to just use the equation FSC equals to 0.87 Fy, and the value of Fy in the given data is given as 250. So we will input this value and we will get the value of FSC as 217.5 Newton per mm square. So we achieve both the values FCC and FSC. Now, as we have to compute the moment of resistance mu, we will first need the value of depth of neutral axis, that is XU. So we will go for the value of XU. Now, to find depth of neutral axis XU, we have the equation C1 plus C2 equals to T. Therefore, equation of C1 is 0.36 FCK B into XU plus equation of C2 is FSC minus FCC into ASC, and equation for tension is 0.87 Fy AST. So only the value of XU is unknown for us and that we have to calculate. Therefore, 0.36 into FCK is given as 20 into value of B is 230 into XU, that is unknown, plus value of FSC. We had calculated here FSC is 217.5 and FCC is 8.92. So we will put both the values. So plus 217.5 minus 8.92 into ASC we had calculated in the first step as 402 equals to 0.87 into value of Fy as 250 into AST in the previous step we had calculated as 1256. So after solving this equation we will get 1656 XU plus 83849.16 equals to 273180. And after simplifying the same equation, we will get the value of XU as 114.33 mm. So this is the value of depth of neutral axis XU. Now we have to check the section whether it is over reinforced, under reinforced or balanced section. Hence for that we have to use IS 456 2000 page number 70, and for FE250 we have the equation for XU max as 0.53 D. This equation is given in IS 456 2000 page number 70. So after putting the value of small d, that is effective depth, as 450, as the overall depth is given as 500 mm, so the effective depth will be 500 minus cover, that is 50, which will be equals to 450 mm. So here you will get XU max equals to 238.5 mm. And in our case, XU depth of neutral axis is less than limiting depth of neutral axis, that is XU max. Hence, our section is under reinforced section, and therefore we have to consider the value of XU as 114.33 mm that we had calculated here. Now, as the depth of neutral axis has been calculated by us, now we have to go for moment of resistance. So for moment of resistance, we know the equation mu equals to C1Z1 plus C2Z2, and value of C1 is 0.36 Fck B into XU, and value of Z1 is D minus 0.42 XU plus value of C2 as Fsc minus Fcc into ASC, and Z2 as D minus D dash. This equation has been studied earlier in the basic concepts. So after putting the values, we will get the value of mu as 0.36, FCK is given as 20, width is 230, and value of XU we had calculated in the first step as 114.33 into value of D as 450 minus 0.42 into 114.33 plus FSC 217.5, FCC 8.92, ASC 402 into D minus D dash, that is effective depth is 450 and compression cover is 50. So we will get 76.10 into 10 raised to 6 for this portion, plus for this portion we will get 33.54 into 10 raised to 6. So the summation of both these values will 109.64 into 10 raised to 6 Newton into mm, which will be equals to 109.64 kilonewton into meter. This is the value of moment of resistance mu. So this is the basic steps to solve the problems related to the WRC beam. Now we will go for the another example. So an RCC beam is 240 mm wide. Here width is given as 240 mm and 500 mm deep overall. So here overall depth is given as 500 mm. It is reinforced with 4 numbers of 16 mm dia bars as compression reinforcement. So here ASC is given as 4 numbers of 16 mm dia and 6-20 mm dia bars as tensile reinforcement. So here AST is given as 6-20 dia and a cover of 25 mm on compression phase. So here on compression phase the cover is given as 25 mm D dash and a cover of 40 mm on tension phase. So in tension zone the cover will be 40 mm. So the effective depth will be 500 minus 40 equals to 460 mm. And we have to use M20 concrete and Fe415 grade to compute the moment of resistance Mu. So now we will go for the given data. So here Fck is given as 20 Newton per mm square. Fy is given as 415 Newton per mm square. Area of steel in tension zone, that is AST, it is given as 6 dash 20 diabars. So here 6 dash 20 diabars. Now from SP16 page number 229, you will get the value of AST as 1885 mm square, and value of ASC is given as four numbers of 16 diabars. So using SP16 page 229, you will get the value of ASC as 804 mm square. And here small d is 460 mm, 500 overall depth minus tension cover 40. So we will get small d equals to 460 mm. Now, as we had calculated AST and ASC, now our next step will be to find FCC and FSC. So, as we know that FCC equals to 0.446 FCK. This equation is given in SP16, page number 13. So, FCC will be equals to 0.446 into value of FCK is 20. So, you will get FCC equals to 8.92 Newton per mm square. Now we have to find the value of FSC, and as the grade of steel is 415, so we have to use the equation d dash by d. So value of d dash is given as 25 and the effective depth we had obtained as 460. So we will get 0.054. Now FSC values will be obtained from SP16 page number 13, table F, and you will get the value of FSC as 354 Newton per mm square. So this is the basic calculations regarding the AST, ASC and values of FCC and FSC, as all these values will be helpful for us while calculating the depth of neutral axis. Now we will go for depth of neutral axis, that is XU. That is, we have to find depth of neutral axis. Now we know the equation C1 plus C2 equals to T. Therefore equation of C1 is 0.36 FCK B into XU plus equation of C2 is FSC minus FCC into ASC equals to, equation for tension is 0.87 FYAST. So after putting all the values, we will get 0.36 into FCK is given as 20, width is given as 240, and XU is unknown for us. So we will simply write here XU plus FSC we had calculated in the previous slide as 344 and FCC as 8.92, into ASC 804 equals to 0.87 into value of Fy is 415 into AST as 1885. So after solving this equation, we will get 1728XU plus 277444.32 equals to 680,579.25. And simplifying the same, we will get the value of XU as 233.29 mm. This is the value of depth of neutral axis. Now we will check whether the section is over reinforced, under reinforced or balanced section. And as we know that for FE415, the limiting depth of neutral axis XU max is 0.48 d. So putting the value of effective depth small d that we had obtained earlier as 460, so we will get the value of XU max as 220.8 mm. Now here the value of XU is greater than XU max, hence our section is over reinforced section. So XU, that is 233.29, is greater than XU max, that is 220.8, hence the section is over reinforced section. Hence XU equals to 220.8 mm. As we discussed in the previous lecture also, whenever the section becomes over reinforced, we have to choose the minimum value from XU or XU max, and here the minimum value is 220.8 mm. Hence we will take the value of XU as the minimum value, that is 220.8 mm. Now, by this way, we have to calculate the value of depth of neutral axis, that is XU. Now, we can put the value of XU in the moment of resistance equation, that is Mu equals to C1Z1 plus C2Z2. Now, we will find the moment of resistance Mu, and as we know that Mu equals to C1Z1 plus C2Z2. So equation of C1 is 0.36 into Fck into B into Xu, and equation for Z1 is D minus 0.42 Xu plus C2 is Fsc minus Fcc into ASC, and Z2 is D minus D dash. So inputting all the values, 0.36 into Fck is given as 20, width is given as 240, and Xu we had calculated in the previous slide as 220.8 into value of D we had obtained as 460 minus 0.42 into XU is 220.8 plus FSC we had obtained earlier as 354 and FCC as 8.92 multiplied by ASC 804 into small d 460 minus d dash cover for compression reinforcement 25. So after solving this, we will get 260.80 into 10 raised to 6 Newton into mm, which will be equals to 260.80 kilonewton into meter. So this is the computed moment of resistance mu. So you have to find the moment of resistance, or you have to analyze the WRC beam using this method. Firstly, you have to check the area of steel and area of compression steel. And for both zone, after finding the value of AST and ASC, you have to calculate the value of FCC and FSC, and then you have to calculate the depth of neutral axis, and in that portion you have to check the section, whether the section is over reinforced, under reinforced, or balanced section. And for over reinforced section, we have to choose the value from XU and XU max, that is the minimum value. And after inputting the minimum values for over reinforced section, we have to find the moment of resistance mu using the equation C1Z1 plus C2Z2. By this way, you have to compute the moment of resistance. In our next lecture, we will design the examples related to the WRC beam. In the analysis portion, till now we had seen that the cross section of the beam and the reinforcement, that is steel, are already given in the data. We have to just compute the depth of neutral axis, that is XU and MU. So this way you have to do the analysis related to the WRC beam. In the next lecture, we will study the examples related to the WRC beam. Thank you.